A customer says, "Cancel my latest order." Your agent has three tools: Helper 1, Helper 2, and Update. The model calls Helper 2 with ID latest. The application programming interface, or API, rejects it. Your harness asks the model to fix the JavaScript object notation, or JSON. The model tries Helper 2 again, then Update, then invents an order identifier. Now you have a loop, no cancellation, and a support ticket. The bug is not the model being weird. The bug is that the tool definitions gave it almost nothing useful to decide from. The first version usually copies normal internal code. We expose whatever functions already exist, keep names like fetch, process, or util, and write descriptions like gets data or use this for orders. That feels fine to us because we know the system. The model does not. It sees a menu of text descriptions and must choose one under uncertainty. If 10 tools sound similar, the model guesses. If every input is an optional string, invalid calls look acceptable. If the description only says when to use the tool, not when to avoid it, the model overuses it. Tool design is not plumbing only. It is part interface design, part prompt design, and part validation. A tool definition is a prompt in disguise. The large language model, or LLM, reads the tool name, the description, and the input schema before deciding whether to call it. The name should say what the tool does. Search orders, not Helper 2. The description should read like documentation for a distracted junior developer. Use this when these conditions are true. Do not use it when these other conditions are true. And this is what the result means. The input schema is your first validation layer. It should include types, required fields, and enums where possible. My bias: 4 sharp tools beat 10 vague tools. Here is the practical shape. Start with the real function signature, def search orders, customer ID, status, any. Then create a stable tool name, search orders. Next, write a description with 3 sentences: what it does, when to use it, and when not to use it. Then write the input schema. Customer ID is a string and required. Status is a string enum, any, open, shipped, cancelled. If the user did not provide a customer identifier, do not let the model fake one. Ask a question or use a separate lookup tool. The flow is simple. User request, model chooses tool, your code validates arguments, then your code runs the function. Suppose we are building a small order support agent. Weak version: lookup database tool, order helper, action tool, and notes tool. Stronger version: search orders, get order details, cancel order, and create support note. Search order says, find orders for a known customer. Use when the user asks for a list or says latest order. Do not use to cancel or modify anything. Cancel order says, cancel one specific order by order ID. Use only after the order ID is known and the user clearly requests cancellation. Do not use for refunds, address changes, or vague requests. Now the model has boundaries. It can search first, inspect details second, and only cancel when the required identifier exists. Good definitions reduce errors, they do not eliminate them. If search orders and find order mean almost the same thing, you are back to guessing. If your schema accepts a giant freeform object, the model can stuff anything inside it. If required fields are not enforced by your code, the schema is decoration. Another trap: descriptions that are too clever. Do not write legal contracts. Write clear operating instructions. Also, the model may call a tool when it should answer from context, especially if every description sounds tempting. Say when not to use the tool, right in the description. Finally, set turn limits. Bad tool definitions plus unlimited retries become production loops. Tool definitions sit in the middle of the agent. The role says who the agent is. The goal says what it is trying to accomplish. The tools say what actions it may take. Permissions say what actions require confirmation. State and memory tell it what has already happened. Retrieval Augmented Generation, or RAG, may provide documents, but tools change the outside world, or query live systems. That is why their definitions need more care than normal prompt text. In later episodes, we will connect this to tool selection, execution harnesses, retries, permissions, and termination. The definition is the contract between model reasoning and your real code. Try this safely on your own machine. You do not need a real provider call. Write 6 fake tools for a notes app: helper, search, update, manage, get, and action. Give them vague one-line descriptions. Then rewrite them into 3 sharp tools: search notes, create note, and update note title. For each one, write a name, a 3-sentence description, and a schema with required fields. Add an enum where it helps, maybe search scope, title, body, or both. Now write 8 user requests and decide which tool should be called, or no tool. If you cannot decide consistently, the model probably will not either. 3 beats to keep. First, the tool description is prompt text. The model reads it to decide whether the tool belongs in the next step. Second, the name matters. Search_orders gives the model a useful clue. Helper 2 gives it a shrug. Third, the input schema is your first validation layer, so use types, required fields, and enums instead of one big optional string. The rule of thumb is simple. Write tools like documentation for a distracted junior developer. New Agent Foundations episode daily. If you want the deeper production patterns, the paid libraries and walkthroughs at ailslabs.ai go further.